Welcome to another video lesson. Today we're going to begin Unit 8, One Variable Statistics. We're going to begin by talking about types of data, and more specifically quantitative data. Let's begin. Our first definition is a random variable, and that is a quantity that can have a value recorded for it or a quality or attribute assigned to it, which is pretty much anything. We have two specific types of random variables. Our first one is a categorical variable, which is a characteristic or a quality. Usually this is something that you would use to describe someone or something. We also have a quantitative variable, which is a numerical value. And that's what we're going to focus on more for this chapter, but we will be dealing with both of these types of variables. Now we have a few examples here, and we're going to look at them and decide if they are categorical, meaning they have a quality, or are they quantitative, meaning that they have a numerical value assigned to them. So for our first example, we have the weight of a newborn baby. This is definitely going to be quantitative because the weight of the newborn baby is going to be in pounds normally, and that is a numerical value. Then for next example, we have score out of 30 on a test. Again, your score is a numerical value, so that's another quantitative variable. Method of getting to school, that describes how you get to school, maybe walking, riding a bike, or driving. That is a categorical variable because it's describing something. And finally we have gender. This is again a categorical variable because it's describing something about the person. Within our quantitative variable, we have two specific types of numerical quantities. We have discrete, which are kind of like finite variables. They have a definite value, or we have continuous, where it's usually a result of measuring. So we're going to do the same exercise here. We'll get two different types of variables and compare them. For our first example, we have the weight of a newborn baby. Now again, is this measuring or this is an exact number? Usually you're measuring, so this would be a continuous variable. The next one is a score out of 30 on a test. This is going to be a discrete variable because you get an actual number. You get 20, 21, 22. It's not going to be usually a range of values. It's going to be a very exact value. The number of people in a household. This is again going to be discrete because, as we discussed in the past, you can't have a portion of a person, you have a whole number of people. And then finally we have height. Again, this is a result of measuring, which is your kind of key attribute for continuous variables. So again, discrete is a finite number, an actual value, whereas continuous is usually the result of measuring, and it's got a range of values. Once we have our random variable, we have different types of graphs we can use to describe them. Here we have a dot plot, and if you look at our dot plot, there's a few things to kind of notice. To begin with, we have our x-axis are the different things a variable could take on, and then our y-axis is kind of just like the frequency. So whatever a variable was, in this case the 3 happened twice, the 4 happened more than that, so 2, 4, 6, 8, 9 times. And then we have, again, all of these represent the 5s, the 6s, and the 7s. So again, your x-axis is your variable and what it represents. And then your y-axis is how many times that variable has occurred. We'll be using frequency tables a lot, not necessarily the tally, which is in the middle, but for your frequency table, you have your variable going down in your first column, and then usually you're performing the experiment. We did this with a Hershey Kiss lab where we had to write down tallies and then turn them into your frequencies. Now we're going to be using this a lot because we'll be taking our frequencies and converting those into a histogram later in this section and also later in the chapter. But again, you have the actual variable, the different things it could take on, and then the frequency is how many times that happens within an experiment. And last but not least, a stem and leaf plot. I want to make sure we're comfortable with this and how to read it. So the stem is the tens unit, sometimes hundreds unit of the number, and the leaf would be the ones. So for first number, the 0 and the 9 would be the number 9. The next number, 1 and 7, would be the number 17, and then 1 and 1 would be the number 11. It's important to note here though that if your numbers repeat more than once within your experiment, you would write that number down more than once. So if you look down here at our 3s, we have a 3 with the 5, and there's 2 5s, meaning that we have a 35 that occurred twice. And if you look at your 2s, we had a 2 and a 6 twice, so you would have 26 that occurred twice. So with the stem and leaf plot, you'd write down every single outcome of your experiment. Once we have our graphs, there's a few things we can notice about them. Again, this would be probably for the dot plot or histogram. We can talk about their skewness. Ideally, we'd like to find something that is symmetrical, which means that we have the mode of the mean in the middle, and it's identical on either side of that line. That doesn't always happen though, so we have two other types of distribution we'll be looking at. We have positively skewed or negatively skewed. And what those mean, we'll talk about the positively skewed first, is you have one large positive value over here that is kind of forcing the data to be skewed towards that number. So it would be symmetrical, but then you have this one big positive value pulling it that way, which is why it is positively stretched. We also have negatively skewed, kind of the same concept. It would be symmetrical, except we have that one negative value pulling it all the way over to the left. Alright, we're going to try and wrap this all together in an example here. So, our experiment is measuring the amount of charge cards or credit cards that a student has on campus, which means that our variable, we're going to call it x, is going to represent how many charge cards somebody has. So the first thing we're going to talk about is what kind of variable do we have here. It's definitely going to be quantitative because it's numerically based. And then the next question would be, is it discrete or continuous? In this case, it's going to be discrete because you have whole numbers of charge cards, 0, 1, 2, 3, etc. And we're not measuring anything, which is why it would not be a continuous random variable. So instead we have a quantitative discrete random variable. Okay, so for our experiment, we went and asked several individuals how many charge cards they had. This is our results. We want to make sure that we can read them. And so if you look at the results, there were 2 people who had 0 charge cards or credit cards. 4 people had 1. 5 people had 2 cards. 7 people had 3. 3 people had 4 cards. 2 people had 5, and 0 people had 6. So again, this is the number of cards somebody had, and this is how many times we counted an individual who had that amount of cards. Once we have our frequencies, we'd want to turn those into a histogram. And so, to do that, we would just have the height of the frequency represent the height of each histogram. And now we can look at a graph and talk about the distribution. This is not exactly symmetrical. If we kind of look at our distribution, it's more kind of skewed. And if you look at that, that's because there is a higher concentration of smaller numbers. So it's going to be skewed to the left or negatively skewed. If we had a higher concentration of numbers over here to the right, then we would have a positively skewed distribution. Alright, that does it for notes today. Go ahead and start the homework.